All right, so we're going to kind of take what we learned in the last lesson with completing the square, and we're going to do a little magic and turn that into the quadratic formula. Now, we don't want to lose completing the square because we're going to use the techniques in completing the square to do some other things like converting standard form of quadratic into vertex form and some other things. So we don't want to lose that information. So this isn't kind of like solving a system or a quadratic by graphing or quadratic equation by graphing or whatever, where we kind of learn it to know a thing and then we don't really use it again. This you will still use completing the square, so we're not going to throw that out. But solving a quadratic, there's another method for equations that don't factor, and that's the quadratic formula. Now what we're going to start out with is, oh my gosh, what is that? We're going to start out with looking at the derivation of the quadratic formula. Now, we're not going to spend a lot of time about this. I tend to kind of skip over these parts, like where we derive the distance formula from the Pythagorean theorem and some of these other things. But it's easy as we kind of get into these sort of complicated formulas to kind of forget where they come from and kind of miss some of the connections. So I'm not going to walk through every piece of this derivation, and by no means do you have to memorize it. But basically, I wanted to show where we get the quadratic formula, which is of course this guy, right? This is the quadratic formula. I've got it on another slide here coming up, but it comes from taking just the generic standard form of a quadratic equation and completing the square on it. So see, we took and divided a by everything because a has to be 1 in order to do it, and then we did a space, and we did the green part that we learned last time. Now it looks a little bit weird because b in this case is actually b over a, right? So it's b divided by 2, or like we said on the thing where it's times a half and then squared, and then we continue to walk through. You can pause the screen and take a look at and look at some of this abstract algebra stuff here, and how we get from here all the way to the quadratic formula. The quadratic formula, of course, and you may probably almost certainly have seen this before in Algebra 1, but this is the quadratic formula. So if we have a standard quadratic equation, then we can solve for x by using this formula, negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. All right, there you go. So let's take a look at actually using the quadratic formula in a few examples. So we're going to solve x squared minus 10x equals 11 using the quadratic formula. This is kind of similar actually to one we saw in the last lesson. We're going to do this one with the quadratic formula instead. So in order to do this, in order to solve this with the quadratic formula, we need it in standard form. So the first thing, of course, we would do would be to subtract 11 from both sides, right? Because we got to move the 11 over. So we would end up with x. That's ginormous. Let's get a little bit smaller brush here. X squared minus 10x minus 11 equals 0. So here we have it. We're going to use the quadratic formula. The quadratic formula again is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right? That's what it is. So we need to know what a, b, and c are. So a in this case, there's nothing there. If there's nothing there, then it's a 1. B is negative 10, and C is negative 11. So now it's just simply a matter of substituting those numbers in here and then just crunching those numbers and getting a solution. So we're going to have x equals, it's a weird looking x, probably could have left it, it wasn't that bad, and negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to substitute in here. For b, we've got negative 10. B, we've got negative 10. A, we've got 1. C, we've got negative 11. Oh, I don't know what I did there. How about we do that, and then we put 2A. So we're putting a 1 into there. Now we just got to do the math, right? Now we just got to do the arithmetic, essentially, and knock this out. So this equals negative 10 is positive 10 plus or minus the square root of b squared, which would be 100. Negative 10 squared is 100. It's positive 100 because a negative times a negative is 100. Or she is 100. A negative times a negative is always 100. No, a negative times a negative is always positive, right? Okay, so then negative 4 times 1 times negative 11 is positive 44. And then 2 times 1 is 2. So then we've got 10 plus or minus 144 all over 2. Square root of 144 is 12. So 10 plus or minus 12 all over 2. So 22 over 2. That's for the plus version. 10 plus 12 is 22. And then we've got negative 2 over 2. That's for the minus version. 10 minus 12 is negative 2. So then our answer is x equals 11 and negative 1. Right? So, and a note on that, it's still easier to do a problem like this, one that does factor, by factoring. If you get to the answer and you get to the end, you're like, oh, dang it, I should have factored. Don't go back and redo it and factor it. And we know that this one could have factored because we've got rational numbers as our answers. If we come out with rational numbers, not irrational, but rational numbers, anything that can be written as a fraction, then it could have factored. We kind of did some craziness for nothing, but, well, not for nothing, but, we could have done it differently, and that's okay. Let's do the next one. All right, so we've got A equals 1, B equals 8, and C equals 16. We're going to plug it in the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So then we're going to plug in here 8, 16, no, for AC, so 1 and then 16. That won't actually change that answer there, but, for consistency's sake. So then we've got x equals negative 8 plus or minus the square root of 8 squared is 8 times 8 is 64. My brain was trying to say 48 for some reason. I don't know why, but, and then 4 times 16 is 64. What is happening? What's going to happen? Something nice. 64 minus 64 is 0. So negative 8 plus or minus 0 all over 2. Plus or minus 0 is the same either way, right? So it's going to be negative 8 over 2. We only have one answer, so this is one of those where it just kind of kisses the x-axis if we put a f of x right there, right? And we're to graph it, right? So our answer is x equals negative 4. All right, let's do another one. All right. So this time we've got a that's not 1 this time. This time we have a equals 2. B equals 6 and C equals negative 7. Now this time we don't have to there's no, oh no, there's nothing something I haven't told you. We got to make A be a 1. No, A can be it can be other numbers. It doesn't have to be a 1 for quadratic formula. That's only specifically completing the square. Any of the other methods that we've learned or learning, they can be different, right? So then we're going to plug it into the formula. So x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. We're going to plug it in as 6 and 2 and negative 7 and 2, right? So we've got negative 6 plus or minus the square root of b squared, which is 36, plus 56, all over 2 times 2 is 4. Right? 36 plus 56 plus or minus the square root of the 92 over 4. Now, if we go to our calculator and punch in the square root of 92, oh, the square root, where is it on this thing? I know it's, oh, there it is, right there where I expected it to be. Square root of 92, we get an ugly number. So we got to see if we can find if this reduces. So are there any perfect squares that go into 92? So 92 divided by 4, that works. So let's do that. Was it 23? 23. X equals negative 6 plus or minus the square root of 4 times the square root of 23. 23 is prime, so it's not going to reduce any further, over 4. So then this would equal negative 6 plus or minus 2, because the square root of 4 is 2, times the square root of 23. Now we're not quite done, because every single one of these is divisible by 2. So we can reduce them all by 2. So x is going to equal, in exact terms, we could punch the square root of 23, get the decimal equivalent, and do that. And if this was like a physics problem or something, then that's probably what we would want to do. But in a math class, especially a little bit higher high school math class like this one, we like to keep our answers exact. So we're dividing all these by 2. So negative 3 plus or minus the square root of 23 over 2. And that's the answer. That ugly looking thing is the answer. That is the answer in exact terms. And you're like, well, should we have 2 answers? Well, we do, because that's the plus or minus, right? So, and if we, like, again, if we're talking about physics or something else like that, then we would actually get the decimal equivalent and we'd get what it's approximately equal to, and we'd use significant figure rules and all of that stuff. But this is good enough for us. In fact, this is better for us. We don't want the decimal equivalent, right? All right. So let's do that one with the quadratic formula. Oops. With the quadratic formula. Forgot to write that out, right? So let's do it. This, again, we got to get this 10 over there. So we're going to add 10 to both sides, plus 10 plus 10. So we're going to have x squared minus 6x plus 10 equals 0. So a is 1, b is negative 6, and c is 10. We're going to plug it into the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'll say it again. I almost wrote a randomly. All right. So negative 6, 1, 10, 1. That's kind of ugly. Let's fix it. 1. All right. So negative 6 is positive 6. So 6 plus or minus the square root of negative 6 squared is positive 36, right? Easy mistake to make. Minus 40 You may be flashing a red flag. You may be seeing something. Are you seeing something? Let's see in a minute. Because this is going to equal 6 plus or minus the square root of negative 4. What does that mean? It means we're going to have a complex answer over 2. Right? So, square root of negative 4. Well, the negative is going to pop out and it's going to be I, right? And the square root of 4 is 2. So this is going to turn into 6 plus or minus 2i over 2. Now, the same thing we did in the last one. Was it the last one? I don't know. One of the previous examples, whatever. It's all going by. It's in a blur. Just going and blowing. We can divide everything by 2. And so this can turn into 3 plus or minus I. Right? There we go. Almost done. We've got one more topic to quickly hit real quick, and then we're going to be through. You're like, one more topic. We're 16 minutes in. It's not going to take very long. Trust me on this one. It's going to be fine. So the last topic is the discriminant. So it turns out that that bit that's underneath the square root has a specific name, and it is called the discriminant. So b squared minus 4ac is the discriminant. Now, why does that matter? It matters because if we just calculate the discriminant without doing any of the rest of the math or any of the other stuff, we don't even have to worry about the plus or minus or anything, it can tell us something about our function, if we make this a f of x or whatever, it tells us something about the equation. It tells us how many solutions that our answer has. And we're going to look at that with this chart right here. So if the discriminant, so the value of the discriminant, so b squared minus 4ac, if it turns out to be greater than 0 and it's a perfect square, so things like 4, 16, 36, 144, all of those things, right? We've learned what perfect squares are before. Then it turns out that you will have 2 real rational roots. And the graph, if you put f of x equals whatever, right? Then it'll look something like this, right? It'll cross the x-axis in 2 different places. It'll be one of these 2 type of things where it's opening up or opening down, but it crosses the x-axis twice. It also turns out, and it's worth noting maybe, that if it's this one, this top one, then you could have factored it. So there it is. Now, the next case is if the discriminant, if the b squared minus 4ac is greater than 0, so it's positive, and it is not a perfect square, so like the square root of 3 or so something like 3 or 26 or a whole bunch of numbers that are not perfect squares, right? All right, if it's not a perfect square, then you have 2 irrational roots. So irrational numbers, remember, are non-repeating, non-ending decimals. So it still crosses the x-axis twice, as you still have 2 solutions, but they're going to be ugly solutions. They're going to be solutions of non-ending, non-repeating decimals, okay? So now if the discriminant turns out to be 0, we had one of these in this lesson. Actually, we had one of every one of these things as examples. If the determinant turns out to be 0, then you only have one rational real solution. So that's a case if it's the function, then it's where it just touches and just kisses that x-axis. It only touches it once. And then finally, if your discriminant b squared minus 4ac is less than 0, so if it's negative, then you have 2 complex roots. So it's going to have i's in it, right? And that's something like these where wouldn't actually cross the x-axis. And that's all there is to the discriminant and solving quadratics using the quadratic formula. We're getting really close to the end of this unit. Thanks for joining us. Hope you've had a great time. I know I have. If you're one of my students, I'll see you in class. Do your homework, all of those things. Do it on time. Don't wait till the last minute. If you already have, then, sorry. Good luck with that. Hope it works out well for you. If you're not one of my students, then thanks for joining us. Hopefully this is helpful. Let us know how else we can help you with math, science, almost said or social studies. No, don't ask me about social studies. But if you want to know about homeschooling, you can ask about that. We'll see you later. Bye-bye.